Right, hello everyone, this is section 9.3, mutually exclusive events. Now, let's the English of that. Mutually exclusive. In other words, two or more events that simply cannot happen at the same time because they exclude each other. For example, throw a fair die, or dice as they say. I cannot have a 1 and a 2. By getting a 1, I exclude getting a 2 or anything else. By getting a 2, I exclude the possibility of getting any other number with that first throw. So certain events are mutually exclusive. Now, if I add up all the probabilities of all mutually exclusive events, I will get a total of 1. In other words, all these mutually exclusive events added up probability wise will give me a certainty that one of them is going to happen with one throw, say, if we're talking about dice. Here's an example, looking at page 119. If I roll a 1 and roll a number less than 5, are they mutually exclusive? No, they're not, because I can get a 1 and 1 is less than 5. 1b says roll a 2 and roll an odd number. Are they mutually exclusive? Yes, they are, because if I roll a 2, I cannot have at the same time an odd number because 2 is clearly even, etc., etc. Let me just jump into some real questions here, and these ones I'm actually going to write on the bit of wood there, that's the screen at the back. Right, question 2, Georgina. It's about Georgina. The probability that Georgina will wear black on a Saturday is 0.5. So the probability that Georgina will wear black, you're allowed to do this if you want to, is 0.95. Did I say 0.5? I meant 0.95. So the probability that she will not wear black must be everything minus the probability of wearing that black. In other words, 1 take away 0.95, 0.05. That's the probability that Georgina will not be wearing black. Because I said, all mutually exclusive events, that is to say, wearing of black or not wearing of black, there's only two possible events there. And there's only 2 events, and so 1 take away 0.95 leaves you the leftover probability for the event of not wearing a black. And that's that one for question 2. Question 3, the probability that Mike will have fish and chips for dinner is 0.7. Yeah, I'll call it F. And C, fish and chips, is going to be 0.07. This is Mike we're talking about. What is the probability that Mike will not have fish and chips? The probability of it not occurring is going to be 1 take away 0.07. I could do that in my brain, I think. 0.93. Yeah, that works. Besides, use a calculator. It's a calculator unit, so don't worry about it. Next one, number 4. I'll fit it just here. It says the probability that Tony will not drink tea at work is 0.01. So the probability of something not happening, not having tea, it's going to be 0.001. Straight away we see that Tony's very, very likely to have a cup of tea. Well, just how likely? Let's have a look. So here she is. 1 take away 0.001 is 0.999. If you add 0.001 onto 0.999, you will get 1. Alright, so that's that in terms of mutually exclusive events. And now I want to deal with some more involved questions. And again, I took the liberty of putting some colours down just to help with the timing of this little vid. Right, a bag contains coloured discs. This is question 6 on page 120. Coloured discs. Each disc has a letter on it as well. So I've got 5 reds with a D, C, F, G, H on it, and 8 blues with those letters, and 2 yellows, as you can see right there. And so what have I got altogether? So I've got 15 discs. If I put a big 15 there, it's probably going to be a very key number for us. So 5, 8, 2, 15. And I've got my A, B, C's and F's, all the rest of it, getting ready to go. A, what's the probability that the disc is red? So probability of a red is, well, let's have a look. I've got 5 out of 15. 5 out of 15. Oops, I'll put 10 there quickly. Get rid of it. 5 out of 15. That's going to be a third. To simplify it down. B, what's the probability of having a disc with an E on it? Well, I've got 1 there, 1 there, and 1 there. That's 3 over 15, which is a fifth. And next one, what is the probability that it does not have an E on it? Well, if the chance of having an E on it is 1 out of 5, then the probability of not having an E must be the other 4/5. Okay, I'm just using my simplified version there. 1/5, I've got an E. 4/5, I don't have an E. Very straightforward. D. It's got to be red or have an E on it. Well, I've got 5 reds straight away. 1, 2, 3, 4, 5. That's got an E. I'm up to 6. That's got an E on it. I'm up to 7. Answer 7/15. Can't simplify it, don't need to really. E. What's the probability that my disc has a yellow, is yellow, or has an F on it? Well, these are my 2 yellows. I can have that F there and that F there. So I've got 4/15. Beautiful, isn't it? Last one. It's got to be blue or have an H on it. So there's my 8 blues. And there's one that's got a blue H as well. Anyway, 8 blues. That H there takes me to 9. So I've got 9/15. Let's simplify that down. 3 goes in there 3 times. 3 goes in there 5 times. Excuse me, 3/5. And that's it. Next question, last question. It's a little bit more tricky, I believe, so let's look at it carefully. Sorry, not last question, the last question. Right, Errol. He's going to go to the supermarket. Let's go yellow now. He's going to go to the supermarket and buy a sweatshirt. Well done him. The probability that he buys it from Super Shirts is 9/20. The probability that he gets it from Best Sweats is 2/5. What is the probability that he can buy it from either one of these stores? Right, so I can go to either there or there. Okay, therefore all I do is add the 2 probabilities. 9/20 or 2/5. Now I know I'm allowed to use a calculator because it's a calculator unit, but I'm not going to do that. At least let's revise how to add fractions. Here we go. 9/20 plus something out of 20. Common denominator or lowest common multiple is 20. Multiply that by 4 to get there. Multiply 2 by 4, 8. So the probability that Errol goes to either one of these places is going to be 17 out of 20. No need to convert it into decimals because we're giving it in fractions, so let's take the hint and stay with it. So what's the probability that he buys it from either one of these stores? Answer 17 out of 20. It's a very likely chance, isn't it? This really is the last question. Let's go dark blue on that. I'll try and get all the answers with this little table here. A bit of a complicated arrangement. That's a photograph of traffic, presumably, on 3 lanes, maybe the M25, who knows, this is London after all. Right, a local council was looking at traffic flow at a busy junction. Okay, the approach to the junction has 3 lanes, yes. The table shows the probability of a car being in any given lane at any one time. So, left, 0.39, in the middle, 0.60, and on the right hand side, we're about to work it out. Work out the probability of the car being in the right hand lane. Well, you're going to be in either that one, or that one, or that one. These events are mutually exclusive. You can't be in the left lane and in the centre lane fully at the same time. Therefore I can say 1 take away the probability of being on my left and the probability of being in the centre, which is 1 take away 0.45 gives me 0.55. So the probability of being in the right hand lane is 0.55. Put the answer there as well. Alright, very easy. Next bit. The probability of a car containing a single person is 0.77. Now, explain why the probability of a car with a single person being in the centre is not 0.83. Well, the centre is 0.06, and having a single person in the car, that is to say a driver alone, is 0.77. So why shouldn't you add these 2 probabilities and in fact get the answer of 0.83? Answer: you can't do that, because being the single driver in the car and being in the centre lane are not mutually exclusive events. Just rub it out. Not mutually exclusive events. In other words, it is possible to be a single driver within the car and to be in any one of these lanes. Alright, so for example, the probability of me being a single driver driving my car is 0.77. Supposing I wanted to be a single driver in my car in the outside right hand lane of 0.55, you can see adding these two probabilities gives you a probability way above 1, and we can't have above 100%. So it doesn't make sense to add events which are not mutually exclusive. Alright, so you can't do that. So best answer, these events are not mutually exclusive, so you can't add the probabilities. Now we have a little hint there which you can read yourself. I'm just going to jump straight in to answering it. Okay, complete this table. Well, let's take it into two parts. This is a single person being in the left, centre or right lane. Well, irrespective of how many people we're talking about, these events, left, centre or right, are mutually exclusive. Therefore, to find the right hand lane, I just take my 1, take away the 0.33 and take away the 0.05. Alright, so the probability of being stuck in the outside lane is 0.62. All these should add up to 1 if you do the maths on that. This is correct. That's that side done. Now, this side's really, really easy. Having one person in the car or more than one person in the car are in fact mutually exclusive events. You can't have one person in the car and more than one person in the car at the same time. Therefore, more than one person in the car must be 0.67, because that plus that makes 1. More than one person in the car, if it's 0.05, then it's 0.95. Look, it all adds up to 1. More than one person in the car in the right lane, it's going to be 0.38. Is that okay?